Hello, Warhawks. Let's get going with some Carnegie math. We're in chapter 7.4. This is triangle congruency by side, angle, side. We also call that SAS congruency. Here's what it says. If two corresponding sides of different triangles and the included angle, which is important, the included angle is the angle between the two sides, are congruent, then the two triangles are congruent. So this is just an example of where we could use side, angle, side. We notice that we have a side here that's congruent to a side over here. They're both labeled 5. So there's one side. We have an angle here, angle A and angle Z are congruent to each other. So there's an angle. And then we have another side, 7 and side 7 here are congruent. So these two triangles we would have congruent by side, angle, side congruency. Okay, now the important thing is this is the included angle. Notice how angle A is between the sides 5 and 7. That makes A the included angle. Z is also the included angle, and that's the important part. If it's not the included angle, then we don't have enough information, which is like this example right here, where we see, yes, we have two sides that are congruent. There's one, there's one, there's one, there's one. But this angle is not included between the two sides. It would have had to have been right there and right there, which we didn't have. So we don't have enough information to prove. It's not that these aren't congruent. Actually, they are congruent because I copied and pasted them. But we don't have enough information. Another thing to say is, it's kind of funny, but this angle side side does not work. Okay, so if it's angle side side, if it's not the side angle side, then we don't have enough information. It's not that they're not congruent, there's just not enough information. Let's look at another example here of two triangles, and let's see if we can't use side angle side to prove that they're congruent. Now, one nice thing about these two triangles is this is going to be an easy case scenario. First of all, I have a right angle there, and I have a right angle there. I know that because they come together where the X and Y lines come together, which are always right angles. So we have one angle that's already the same. Perfect. Now let's see if we have two sides that are the same. And actually, I want the two sides to be this side here and this side here because the 90-degree angle is the included angle between those. Now let's see if they're the same. Also an easy case scenario here is these are right on the X and Y lines, so I can just count. This is 1, 2, 3, 4, 5, 6, 7 units. This is 1, 2, 3, 4, 5 units. And then over here, let's see if it's the same. 1, 2, 3, 4, 5, 6, 7. Yes, and 1, 2, 3, 4, 5. So those two triangles will be congruent by side, angle. Oops, I already had an angle there. My fault. Side, angle, side congruency. Okay, now let's look at the last case, which is the harder case. Okay, so I went ahead and started off by giving you one of the sides. And this one was easy to find because I could just count it. Now, we're going to want to find an angle. So it's up to you which angle we want to find. But I'm going to find angle B here. I'm going to do that with a protractor. So we can just slide protractors over here. We want to put the middle part right there at B, and then they have a line for us that's going to measure it. And I see that this angle goes from here to there. Now, it looks like it's 135 or 140, but we know that can't be true because this is an acute angle. So we want to use the inside here, and it's really 10, 20, 30, 40. It's right between 40 and 45. So I'm going to say that that's a 45-degree angle right there. And I had to use a protractor to find that. So that angle's 45. Now look closely down here. Which angle down here would really go with B? Well, we had 45 was on the left side of 10, but we've switched that. So really we're looking at angle R to be our 45-degree angle. So let's go ahead and see if we can take our protractor. We flip it upside down because now we want to measure the angles down here. Okay, so I've flipped it upside down. I want to put it on R, line those up, and then again I go 10, 20, 30, 40, 50. It's right there between 40 and 50, so I feel that that is also a 45-degree angle. Actually, I don't just feel that it's 45, I actually measured it. So this is also a 45-degree angle. Now, since I found that angle and I have this side, think about which side I would need to prove that these triangles are congruent by side, angle, side, because remember, my angle has to be the included angle. This angle right here and this angle right here are included between side 10 and whatever AB is. So let's find out where AB is located. A is located at 1, 2, 3, 4. That's my x value, and it's actually -4. And then I go up 1, 2, 3, 4, 5, 6, 7, 8. So -4, +8. And B is located at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, +2. So x was 10, y was +2. Now let's find these. R is going to be located, and again, we're going to find the side length here for RQ. We'll do that in just a second, but I'm going to figure out where it's located at 10, 1, 2, 3. So R is located at +10, -3, and I see where I made a little mistake on B. B should actually be -10. We went backwards 10. And then I want to find out where Q is located, so I go 1, 2, 3, 4. And then I went down 1, 2, 3, 4, 5, 6, 7, 8, 9. So -9. All right, so let's use the Pythagorean theorem to find the length of AB. How far is it from -10 to -4? That is 6 units. So I'd use 6 squared plus, how far is it from 2 to 8? That is, again, 6 units. So we're going to do that to find AB, which I'm just going to say c squared right now. 6 times 6 is 36, plus 36 equals that side squared. We add them together, we get 72. And then I just want to take the square root of 72, grab a calculator, put it in, 72, square root button, and we get 8.5. So this side ends up being 8.5. Okay? That's a 2, not a 7. Was what our missing side was there for AB. Now let's do the same thing down here. How far is it from 10 to 4? Well, again, that's going to be 6. And how far is it from -9 to -3? They're both negative, so the distance there is always positive, which is going to be 6. Add them together, and you can already see that, hey, these are going to end up being the same. We take the square root, and again, we get 8.5 for side RQ. So RQ is 8.5 as well. And that means that this side and this side are going to be congruent to this side and this side. So here we have a side, an angle, a side, side, angle, and another side. So in conclusion, I would say triangle A, B, C is congruent to, now look how I listed this. I said A, I went down the side that's marked 8.5 to B, and then down the side that's marked 10 to C. So I said ABC down here, I need to say is congruent to triangle QRS. And I would say that this is true by side, angle, side. Here's a little quiz question for you. This person pictured down here, this message is approved by him. He is running for president in the Republican Party. He's from the state of Florida. What politician is that? Well, it's Marco Rubio. That'll be a little quiz question for you. Hope you enjoyed it, and we'll see you in class.